For generations, astronomers have dreamed of seeing a distant planet not as a faint signal or a mathematical possibility, but as a real world with an atmosphere, chemistry, and a story of its own. The James Webb Space Telescope has brought us closer to that reality than ever before. What Webb has revealed is far more surprising than a collection of distant planets. Some worlds appear to possess unusual atmospheres, unexpected chemistry, and conditions that challenge the models scientists once trusted. One of the most fascinating examples is K218b, a planet larger than Earth and located far beyond our solar system. Webb observations have revealed an atmosphere containing several important molecules, including water vapor, methane, and carbon dioxide. Scientists have also investigated evidence for other carbon-based compounds that could provide clues about the planet's environment. K218b is especially interesting because researchers have proposed that beneath its thick atmosphere there could be a vast water-rich environment. However, scientists are still studying whether its conditions are actually suitable for life. Detecting interesting molecules is not the same as discovering life, and much more evidence is required before such a conclusion could be made. Another remarkable world is HIP 65426b, a massive planet located at an enormous distance from its parent star. Unlike most exoplanets, which are detected indirectly, this world has been directly imaged. Webb's powerful infrared instruments have allowed astronomers to study its atmosphere and temperature in greater detail. Its existence also raises questions about how enormous planets can form and evolve. Traditional models suggest that giant planets should develop within the dense material surrounding young stars. Yet worlds like HIP 65426b demonstrate that planetary systems can be much more complicated than simple formation models suggest. Some researchers have considered whether planets like this could have migrated from different regions of their systems. Others are investigating alternative formation scenarios. Each possibility gives scientists another piece of the puzzle. Then there is Proxima Centauri b, one of the most intriguing planets in our stellar neighborhood. It orbits Proxima Centauri, the closest star to our Sun, and lies within a region where temperatures could potentially allow liquid water under the right atmospheric conditions. That sounds promising, but the planet faces a major challenge. Its star is an active red dwarf capable of producing powerful stellar flares and intense radiation. Such activity could affect the planet's atmosphere and make its surface environment very different from what we might imagine from its location alone. There is also another problem. Observing Proxima Centauri b directly is extremely difficult because the planet is overwhelmed by the brightness and activity of its parent star. We know the planet exists, but learning what its surface and atmosphere are truly like remains a difficult scientific challenge. Webb has also transformed our understanding of hot gas giants such as WASP-39b. This enormous planet orbits extremely close to its star, creating an atmosphere where temperatures are intense and chemical reactions occur at remarkable speeds. Observations revealed water vapor and several other molecules, while sulfur dioxide provided particularly interesting evidence. Scientists found that stellar radiation can drive chemical reactions in the atmosphere of another planet, producing a form of photochemistry that had previously been difficult to observe beyond our solar system. WASP-39b therefore acts almost like a natural laboratory. Its environment is completely different from Earth's, yet the same basic laws of chemistry and physics operate there. And this is one of the greatest lessons from Webb so far. Planets do not need to resemble Earth to be scientifically fascinating. The TRAPPIST-1 system provides another important example. It contains 7 roughly Earth-sized planets orbiting a small, cool star. Several of them attracted enormous attention because their locations could potentially allow temperatures suitable for liquid water. Scientists hope that Webb would eventually reveal atmospheres around these worlds. But studying them has proven much more complicated than expected. Strong stellar radiation may have significantly affected some of the planets, and determining whether they possess substantial atmospheres requires careful observations. This uncertainty is important because simply placing a planet in a potentially habitable region does not guarantee that it is actually habitable. A planet needs more than the right distance from its star. Its atmosphere, magnetic environment, chemistry, temperature, and geological activity can all determine whether conditions remain suitable for life. And that brings us to one of the biggest mysteries Webb is helping scientists investigate. Our galaxy appears to contain an enormous number of planets. Some are frozen. Some are extremely hot. Others may contain oceans, thick atmospheres, or unusual chemical environments. Yet despite all these possibilities, humanity has still not confirmed life beyond Earth. That silence is one of the most fascinating parts of the search. Every new observation gives scientists another opportunity to investigate the ingredients associated with habitability. But finding water, carbon-based molecules, or an atmosphere does not automatically mean life is present. The real challenge is finding a combination of evidence that cannot easily be. The discoveries made so far are only the beginning. Every time the James Webb Space Telescope studies another distant planet, scientists gain a new piece of evidence about how planetary systems form, change, and sometimes produce environments that are completely unlike anything in our solar system. One of the biggest surprises is how difficult it can be to determine whether a planet is truly suitable for life. For decades, scientists often focused on a planet's distance from its star. If the temperature could theoretically allow liquid water, the planet was considered an interesting candidate. But Webb is showing that the story is much more complicated. A planet can sit in a promising region and still lose its atmosphere. Another world can have water vapor but experience conditions that make life extremely difficult. A planet can even contain carbon-bearing molecules while having no biological activity at all. This is why Webb's observations are so important. Instead of simply asking whether a planet exists, scientists can begin asking what that planet is actually made of. When starlight passes through a planet's atmosphere, different molecules leave distinctive patterns in the light. Webb can analyze those patterns using infrared observations and identify chemical components that would otherwise remain invisible. This technique has opened a completely new way of studying distant worlds. But there is an important limitation. A chemical signature by itself rarely provides a definitive answer about life. The same molecule can sometimes be produced through biological and non-biological processes. Scientists therefore need multiple observations and several independent pieces of evidence before making extraordinary claims. That careful approach may be frustrating for people hoping for an immediate discovery of alien life, but it is exactly what makes the search scientifically meaningful. Every observation helps eliminate possibilities. Some planets may turn out to be too hot. Others may have atmospheres too thin to protect their surfaces. Some may be covered by deep layers of gas, while others could be frozen worlds far from their stars. And then there are planets that seem to occupy the narrow region where several important conditions come together. Those worlds are among the most exciting targets for future observations. The search is also changing how scientists think about Earth. Our planet is not simply habitable because it is located at the right distance from the Sun. Earth has a complex atmosphere, liquid water, geological activity, a protective magnetic environment, and a long history of chemical and biological change. When Webb studies distant planets, scientists can compare their atmospheres with what they know about Earth's atmosphere. This comparison may eventually help researchers understand which atmospheric combinations are genuinely unusual. It could also help answer a much bigger question: how common are Earth-like environments across the galaxy? The answer is still unknown. We know planets are extremely common, but we do not yet know how often they develop stable conditions suitable for life. That uncertainty makes every new observation important. Even worlds that appear completely hostile can teach us something valuable. Extreme planets reveal how atmospheres behave under intense radiation and enormous temperatures. Giant planets help scientists understand how planetary systems develop. Smaller worlds provide clues about rocky planet formation. Together, these observations create a much larger picture. The universe is not producing planets according to one simple recipe. Different systems can develop in dramatically different ways. Some planets may form close to their stars and migrate outward. Others may form farther away and move inward. Giant planets can influence the paths of smaller worlds, while stellar activity can transform atmospheres over millions or billions of years. Planetary systems are dynamic environments, not frozen collections of objects. And Webb is giving scientists the ability to watch some of these environments in unprecedented detail. The most exciting possibility is that somewhere among the enormous population of distant worlds, one planet may eventually provide a combination of atmospheric signals that cannot be easily explained by ordinary chemistry. If that happens, scientists will need to investigate it carefully. It would not immediately prove the existence of alien organisms, but it could become one of the most important discoveries in human history. For now, the search continues. Webb is scanning atmospheres, measuring temperatures, studying clouds, and examining the chemical fingerprints hidden inside distant starlight. Each observation brings new surprises. Some discoveries will challenge existing theories. Others will confirm predictions. And some may force scientists to completely rethink how planets form and how life could survive beyond Earth. The greatest mystery remains unanswered. Are we the only living world in the universe? We still do not know. But humanity now has an instrument powerful enough to investigate that question in ways previous generations could only imagine. The distant planets are no longer just points in a telescope catalog. Their atmospheres can be studied. Their chemistry can be investigated. Their environments can be compared. And with every new world Webb observes, the universe becomes a little